Greetings to everyone online, and greetings to those who are going to be watching this later on. I guess I'll probably know some of you, but I won't know all of you. I'm Mike Elliott. For many years, I worked for what is now SEPA in Scotland. And then since the 90s, I've been down at the University of Hull, where I'm now an Emeritus Professor there. I think Emeritus means that the university takes credit for everything I do, but without paying me. In addition to that, I'm director of IX Limited, a research company, and I'll mention more about that in a short time. There. So what I want to talk to you about is the way over the last few years our ideas on managing marine resources and hopefully getting sustainable management have developed. And I'll take you through some of the work that we've been doing and we're involved in now. And you'll see at the bottom of the screen there are a set of logos for ongoing Horizon Europe projects, these European projects that even despite the stupidity of Brexit, the UK can still be part of, but we get funded up to last year from UKRI, and from this year we get funded from Brussels, and then go on and that. So just a brief note about IX Limited. Some of you will have known it as the forerunner of that, which was the Institute of Estuarine and Coastal Studies at the University of Hull, which had been in existence since 1982. The university in its wisdom closed it down. So after they closed it down, we formed IX Limited, a limited company carrying out research. And you see there that list of the employees that we've got, and I'm an employee of IX. On the right-hand side of the screen, you can see the sorts of projects that we've been involved in. And I'm going to talk about some of those. And these range from UK projects to European projects to those further afield, like Manila in the Philippines or Namibia or Abu Dhabi and so on there. So, okay, so I can come back to any of those that I mentioned. How to maintain and protect the system to produce ecosystem services from which we derive societal benefits. And of course, just below that, there's a vision that many of you will be familiar with. In other words, this is, we aim to look after the natural stuff and deliver the human stuff. Why do we have to do that? That list at the left-hand side says why we have to do it. We have to cope with our historical legacy. We have to reverse some of these endangered ecosystem functions, and we have legal coping with climate change. There. I'll talk about various papers that we've done over the years, but these are some of the central ones. And if you want copies of these and can't get them, then let me know. But you'll see there how we've had several where we're using the term managing marine resources sustainably. Now, we started using this term and then SMMR came along. Unfortunately, we've got the same words, but in a different order. But some of the ideas that I'm going to be talking about were originally going to be in an SMMR project that unfortunately was successful. So we've gone in other directions to get the work funded. But everything comes together, we hope. There's many developments now within Europe showing the way marine management and marine science is going ahead. And I say this is some of those things. And as far as I can see now, there's about 16 marine projects in Horizon Europe, of which we're partners in 4 of them: Guess for Seas, Marine Plan, MOB-FES, and Marine Sabres. And as you see from that list, there's a lot of things happening within them. And the list goes on and on, as you would expect. So this shows the wealth of marine management and marine science that's being created. This framework, and it's been developed over the decades from originally something called the DIPSIA framework, and it's now, as you see there, it's called the DAPSIWORM framework, where we have drivers, which are our societal basic needs. They lead to our activities. Those activities create pressures, which are mechanisms of change. What are we changing? We're changing the natural stage, the state change on the natural system, and then impacts on human welfare. So we then have to do something. So, for example, in very simple terms, the drivers, we want food. The activities, we go fishing or undertake aquaculture. We lead to that leads to pressures and scraping the seabed and putting things in the water and so on. That, if we're not careful, that changes the natural state. We might remove fish populations. If we keep doing that, it leads to impacts on human welfare. We don't have any fish to catch, and common fisheries policies and so on there. And just very, very briefly, these are what we mean by basic human needs using the Maslow's hierarchy, showing going from basic physiological needs at the bottom there up through more and more esoteric and spiritual aspects with a small s. And you see how these then relate to human well-being. See down the left there, there's a set of activities, and these go for most marine areas worldwide. They lead to pressures, which are the mechanisms of effect. And this set of activities and pressures are what we call endogenic managed pressures. That is, they occur in an area, and both the causes and consequences are managed within an area. In addition to that, we have these things called exogenic unmanaged pressures. Exogenic means managed, created from outside an area. So these sorts of pressures are created, as you see there, probably created worldwide, where the causes have to be managed worldwide, but the consequences have to be managed within an area. So, for example, sea level rise is caused worldwide, but we have to manage the consequences of it locally. And we can think of all of these as creating hazards and risks in the environment. Now, a hazard is something that occurs, and it may be either natural or anthropogenic means, and then it becomes a risk when it affects something that we value. So when it affects our livelihoods and our lives and our well-being. And all of this has been published, and we could spend a long time going through all these hazards and risks. But as you see, that's one set of, even going down to geopolitical hazards, such as wars and migrations and so on there. So we have a set of hazards. These occur, they could be created naturally, like tsunamis, which are there where the effects of those may be worse, may be made worse by human actions, like removing coastal protection from mangroves, for example, or they could be anthropogenic, as you see here. And then bring this marine area that you think of could probably have this set of endogenic managed pressures and exogenic unmanaged pressures. And you see there, these are quite common lists there. So things that you probably all recognize. A little while ago, we summarized this. When we said we needed to try and summarize this for policymakers and politicians, we decided on this thing called the triple whammy. What are the threats for estuaries and coasts worldwide? And this was based on analysis worldwide. But we decided there were three things. Remember, a whammy is like a punch. So the triple whammy is increased industrialization and urbanization, increased use of resources, be physical resources or biological resources, even space is a resource, and decreased resistance and resilience to climate change. So these things are happening worldwide. So we can then say, what do we have occurring in the seas worldwide and in most areas? Now, some of you will recognize this, the diagram on the left being the sea area, the Irish Sea, showing Scotland, Northwest England, Wales, and Northern Ireland coast. This was some work we did a long time ago now, but it just shows how many activities there are in an area. So let's take a stylized version of that and say what occurs within an area. And this shows the boundary between two countries, as you see the dashed and dotted line down the middle there. It shows the things that happen, whether seabed mining, wind farms, oil and gas, fisheries areas, biotechnology areas, and so on. So you see there. And one of the things that we want to think about is not only the management within any one of those national areas, but the management between national areas as well across that, that baseline. And we can think of each of those activities as having a footprint or various footprints. We can think of them having an activity footprint leading to a pressures footprint, an effects footprint, and a management response footprint. And I'll try and explain each of these, but say for those of you who want, there's the text for you to read in more detail later. Okay, the activity footprint. An area might be regarded as having an activity, but usually the activity only covers a small part of that. For example, you see the seabed mining area there, the drag head through that is only a relatively small area. The fishing may only be a relatively small area through it there. And you can see this as soon as you see the pictures of the activity, showing, you know, a drag head that may be no more than 2 meters across, creating a track through an area. The pressures that created from that could be then much wider, because obviously that activity is going to change the water column, it's going to create suspended sediments, it's going to create noise and so on. And those pressures are going to be much wider than the activity footprint. So we say the pressures footprint is rather larger than that there. And you can see this with, again, using the dredger example, the way we then have to talk about near field effects and far field effects. The effects then, and the effects both on the natural system and the effects on the human system are even wider, because we've got the waters moving through the area, we've got organisms moving. Now, an organism that picks up pollutants in one area, they transport them to another. So the effects footprint gets even wider, and we have to try and bear these things in mind. And then on top of that, we've got long distance migrations, birds moving from the high Arctic into estuary feeding areas and so on, and whale migrations through them. And then of course we put on conservation measures, and I'll try and come back to that there. We've tried measuring those activity footprints, and this is a first attempt at measuring them, saying, well, if you take the North Sea, how many activities can you work on in order to determine what the activity footprint is? And as you see from here, if it's difficult enough calculating the activity footprint, it's even more difficult calculating we rely on the activity footprint rather than the pressures and effects footprint. And even with the best estimates, this would say there's probably something like 5 to 10% of the seabed in the North Sea occupied, excluding fishing, because that's even more difficult to calculate there. Let's use, of these ideas I've just shown, let's use a quick example of oil and gas decommissioning. We've been working on this for a while, as you see from some of those papers there. This is a huge problem in Scottish waters and English waters and all around the North Sea. And we can say, well, what are the drivers? The drivers are trying to fulfill some of the legislation that we've got and create a better environment. And you can see how this cascades and gets more and more complicated through the types of activities that we have to address. So decommissioning, but you see how complicated it gets. And the same as then the activities lead to many types of pressures, then starts getting a bit simpler because there's a state change on some of the natural system, and then the effects on human welfare. Now, this was from an insight study we did a while ago, where we were looking at a UKRI study, where we were mainly focusing on the activities and pressures, which is why there's more links there. And then taking another problem that we've just started working on, and that's the footprints of shipping activities. And this is from Professor Hasselhoff in Göteborg that I'm working with. And what we're now trying to look at is the particular problem of a moving footprint that you get from shipping, but that's probably for the next talk after we finish the paper. There, we can then think about how activities can an area hold? How many can they carry? And we have two definitions there: the assimilative capacity and the carrying capacity, which used to have a very well-defined meaning. Assimilative capacity was related to pollution. Carrying capacity was very much an ecological term. But over the last few years, these two definitions have now been taken and used by social scientists as well, in order to look at be held there without adverse effects on it. And we can show that in this model that's been published and then has been used in defining one of the European projects that we've got. If we have no activities in an area, we have high environmental quality. With each activity comes in, we lose some of that environmental quality. We then bring in mitigation measures and we regain some of it. We regain some of the environmental quality. Another activity, we lose the environmental quality, put in mitigation, we regain it. And we keep doing this as each activity gets sanctioned in an area until we get down to this green line, a line that we don't want to go beyond. And in European terms or in UK terms, we might call this good environmental status, for example. And you can see here what the assimilative capacity is for these activities. And by licensing those activities, the aim is to get all of these curves up into this upper area there. So challenge for management in dealing with all of these activities is what industry would just call simple risk assessment and risk management. What are the problems? What changes do they cause? What in essence do we do about them? So risk assessment and risk management is always used by industries, and only more recently as scientists working on the environment. So a while ago, we said, well, if we're dealing with industry, let's use the methods that they are using for risk assessment and risk management. And industry use an ISO technique called the bow tie analysis. So about 15 years ago, working with Roland Cormier in Canada, we started using this. And now this system is well used. The Department of Fisheries and Oceans in Canada use this system for their environmental management. And bow tie analysis is fairly simple. In the middle there, you see an ecosystem event. So that's the knots. That's the problem that you're worried about. Why are you worried about it? Because of these blue boxes that are causes of it. If you can put prevention between the cause and the knot, then you could try and stop your event happening. If you can't stop it happening, you might need to try and mitigate it or help the system right-hand side, which are the consequences. And you see how this relates to the drivers, the activities and pressures, which are our causes, the state change and impact on welfare, which are usually the main knot and the consequences, and the responses using prevention and mitigation, which are these responses using management measures. And you can make this fairly complicated. This is using proprietary software that we use. This was for a paper we were doing led by Darryl Burden in IX, looking at the effects of climate change on offshore wind farms. But actually in some European projects, and this was the Sirius project that we were involved in, which was looking at climate change on aquaculture and fisheries. And we did this not using the proprietary software, but using stakeholders. This, for example, was a set of stakeholders worried about losses and mortality of mussels in mussel farming. What would be the consequences if that happens? And then these green boxes in between, what can we do about it? So using an ISO technique makes this rather more structured, but also it shows the things that industry is using there. And we can give you a recipe for carrying out that bow tie analysis. You see this wall here, which was covered in this system. This was from a workshop I was leading with Lon McWhinney, who's now at Heriot Watt. but we were leading this in British Columbia to look at the effects of navigation on marine mammals. And we're now using this technique in some of these European projects there. The next thing is how we determine what changes have occurred, and we determine it by looking for changes against thresholds or tipping points or reference conditions, having criteria for monitoring, having indicators, and so on. And remember, monitoring, which can be fairly rigorous, monitoring is not a management measure per se, but it's rather a tool to tell you what management measures are required and whether those management measures have been successful. And I haven't got time to go through them, but a recent book that we produced that came out, Andrew Wither and I edited it early in this year, shows the different types of monitoring. And you see all those types of monitoring on legislation and guidelines and so on there. That monitoring, if you're monitoring properly, you must be monitoring against a determined amount of change. The determined amount of change will be what we would call an indicator. And these are lists of the properties of indicators that we've used over the years. And one of the projects, another project we're doing at the moment, not a Horizon Europe project, but one for DG Mari in Brussels, is to look at the way indicators are used in SMMR-Net. And Anita Franco in IX is leading on this there. And as you see, take that DAPSI-worm framework and you'll see there's indicators on all parts of that. So indicators are what we need. And as you see at the bottom there, there's this adage from industry that says you can't manage something unless you can measure it there. One of the biggest challenges we've got is these transboundary areas. Not just managing within one area is difficult enough, but managing across an area, say from the UK coast at the left side there to, I know, the Dutch coast or the Belgian coast at the right hand side. It's trying to cope with those transboundary areas and trying to cope with all of those activities that are occurring at the same. So one of the biggest challenges we've got, and we're working on this in, for example, the Guess for Seas project, is looking at cumulative and in combination effects and assessment there. And there are various systems now of looking at cumulative and in combination impacts and effects assessment. But in essence, it's saying, how do we get a system where we can cope with all of those? And as you see from this diagram from one of Gemma Lonsdale's papers that I was involved in, there are systems now for cumulative and cumulative impacts and effects assessments there. So now let's talk about where the solutions to these problems are going to come from. And some of you have heard me say before that the solutions can be summarized in these things called the 10 tenets. Not 10 tenants, that's a good night in Scotland. The 10 tenets, like soft law. And you see there the things that we have to line up and get in our mind in order to find the solutions to this. And I can't talk about all of those. It's all been published and discussed in many areas now, and other people are using this now. But I just want to talk about a few of these. The first bit is, where are we managing? Well, of course, we're managing everywhere from a small area, the activity footprint, all the way through to the globe. We have global management systems now, like the UNEP Oceans Globe. Many of these things now that we're working on. And I'm involved in the World Ocean Assessment third cycle. I was involved in the World Ocean Assessment 2 as well. And you'll see there the breadth of global initiatives and global changes there. How are we managing these things? Well, we have everything. We've got management action, we have programs and measures, we have monitoring schemes. We link the monitoring to smart indicators. That's indicators that are specific, measurable, achievable, realistic, and time dependent. We implement laws and we have lots of management bodies. And I'll try and explain these very briefly there. all of our countries are signed up to a set of internationally recognized governance aspects, and we define governance as the policies, the politics, the legislation, and the administration. So we're all signed up to these, and many of you will recognize these principles. So how do we put those into operation? We do it firstly through a whole load of legislative instruments. And again, some of you have seen this, it's been around for a while. And more recently in these European projects, we've got 29 groups all over Europe that have just created these for their area there. In the middle, we have instruments. Surrounding those, we have those red boxes, which are all the European directives. The blue circles are what those directives require you to do. And remember, the UK have got their own versions of these now. In fact, many of them are identical to the European ones, thank goodness. And then the green ones are the national legislation. And the purple circles are what that national legislation requires us to do. So we have all of this, and we've done it for many countries now. What we have to do, and around this diagram, we have to integrate from the local out at the purple there to the middle, the international, or vice versa. And we have to integrate around the edges. So bringing in fisheries and navigation and water quality and conservation and archaeology and discharges and renewable energy and so on. So we have to try and integrate both vertically, global to local, and I'm involved with European legislation, and indeed the UK legislation is very similar. This shows you where those different directives occur, but we can discuss all those later. But many of you are familiar with those there. The next point is who is doing the management, and we have all of these different bodies, and again we've created organograms like this one you see on the right, and all these groups these for their areas as well, showing the way you go from the high level government through the departments and ministries to the agencies, and then what they do. And you can see that all countries have got different government departments with marine competency in them. And all these different government departments have got some marine competency. And you can summarize this by this simple scheme. They've got maritime spatial planning bodies, environmental protection agencies, the developers themselves, the port authorities and their regulators, and the nature conservation bodies. And then these circles are some of the things that they do. So when we've examined these, we've seen that these occur in all countries we've looked at. They might have different names, but they do occur in different countries and that. So let's talk about this thing. We take it from having top-down or bottom-up initiatives. This was produced a couple of years ago, and it's trying to link all those, but in a more simpler version. This shows this management response footprint pyramid. The management response footprint goes all the way from a technical measure, which might be quite small, probably less than a hectare. National environmental policy that goes to even bigger areas, regional environmental agreements such as OSPAR and HELCOM, it's getting even bigger, and then global treaties and conventions up to the so you see how this management footprint increases. In the paper in there, we also talk about the numbers of these different initiatives, and that is a triangle the other way around there now. Those bits of legislation. The Marine Strategy Framework Directive, or what would be called in the UK Marine Strategy, but it's the same thing, which aims to protect the natural system through all these descriptors that you see there, 11 descriptors. And then the managing and the planning of the seas is according to the Maritime Spatial Planning Directive, which is again more human based. And indeed, the MSP directive is regarded as programs of measures for the MSFD now. there. And we know the sequence of things like the MSFD, characterizing an area, working out the pressures, getting targets, monitoring them, doing the management, and so on. And in one of the European projects that we're one of the leading, we're leading one of the work packages, Guest for Seas, you can see how we're developing the conceptual framework and knowledge base for ecosystem-based management there. And we've also using with people like Steve Barnard in IX, devising some of the software for determining methods being used in ecosystem-based management. And I can, if anyone wants more details on this, I can give you all the information there. Maritime spatial planning is one of the bigger aspects, and all countries through the MMO in England and Marine Scotland are bringing this in. And we have these increasing spheres of marine assessments now. We have everything. We have all of these different designations that you can see there, all these different types of assessment. And we're now starting to put some of these things together. And you can see there's this whole alphabety spaghetti of conservation designations, and in one of them the similarity between these different designations. And I can't go into it, but these are some of the designations across the top, like ecologically and biologically sensitive areas, particularly sensitive sea areas, and so on. And these show that the features in those. And so we're doing an analysis at the moment, looking at the similarities of those, led by Ava Amarim in IX. So one of the things we then have to think about is the links between these transboundary areas. And I shan't go into it in detail. This was all published last year, but looking at the connectivity between areas, the coherence between areas, and equivalence between areas. And very quickly, these are two areas or other features in across a boundary, are they connected in some way, say the hydrography or the biology? Is the management coherent across areas? That is, we're doing the same thing across a boundary. Or do we have equivalence across a boundary? That is, we're doing different things either side of the boundary, but with the same aim to it. And if you look at the paper, we've gone through all of these different aspects, looking at connectivity, coherence, and equivalence there. So now let's quickly move on to ecosystem. And for a while now, since the early 90s, we've been talking about ecosystem services. And this is one of the original systems of saying we have 4 types of ecosystem services. But as we've examined this more and more, we've realized that there's inherent confusion in this. And the biggest confusion is that it mixes ecosystem services and societal goods and benefits. And as you see there, provisioning could relate to societal goods and benefits. Regulating and supporting is just what a normal ecosystem does anyway. And cultural services, well, nature doesn't know culture. That's something we put on. So then in the last year or so, formalize this into this framework of the marine environment, where we have the natural domain, we have natural capital. This is the way the system is structured and functioning. It produces ecosystem services. There's still internal provisioning, internal regulation, and then that is ecosystem services and natural capital. We have to put in something. We have to put in complementary capital and human assets. We have to add in time, money, energy, skills, knowledge, the ability of being sentient, to turn these ecosystem services and natural capital into societal goods and benefits. So for example, the natural domain can produce fish, but we have to put in time and money and energy to catch the fish. Skills, we need skills to build the restaurants and learn how to benefit from the fish. We put those in and we get these societal goods and benefits. Extracted provisions, environmental regulation, hazard and risk reduction, and cultural, aesthetic and health benefits. And this is the most simple way I can describe this system. But even then, not all environmental economists would agree with this. there. In essence, this can be shown as the marine ecosystem structure and functioning, which is ecosystem valuation. We put in capital and we get out societal goods and benefits, and we can value these in different bits. And that's what we're doing in one of the projects in Marbefes. And I shan't go into it because I'm going to run out of time, but this is ecological valuation, for example, valuing the system irrespective of any financial gain from it. This is the ecological valuation. And in Marbefes, this is the system we're using under leadership by Tiziano Rossetti and Daryl Burden and Anita Franco, both of them in IX, where we are evaluating the ecology, having an economic valuation and social cultural valuation. Okay, so we can decide, well, we can bring all this together by giving integrated marine management. And you see there the things that we need to understand for that. So let's then create finally a system which brings all this together, a systems analysis approach, if you want, or decision support system in order to bring this together. Now, we published this a few years ago now. This is the simple version of a systems analysis approach. We set priorities in block A. We get the information in block B and do something with it. And then we use the information in block C. And this then becomes a rather more complicated system of 14 subsystems. But you can see there we have A, where we've got the issues and the priorities. B, we're gathering the information and making sure the information is good enough to use. And C is using the information in legislation and governance and feedback to hope that we finally get back to A. And you can start off at A with your vision, or you can start off at C as the legislation. And this has now been taken further into the Marine Sabres project, with the integrated social ecological system. There. So let's just bring this together. We start off with this ecological society spine. We've decided we want drivers from the marine system, so we bring it. We carry out activities that involves putting in this complementary asset that gives us the socio-economic benefits, and that fulfills our drivers. But, and there's always a but, the activities lead to pressures. They change the natural and the human system. And if we're not careful, we degrade the system. So we then, we then do something about it. We bring in management measures, we bring in governance, we have adaptive management, and those 10 tenets that I mentioned to you in that. So the final part is we say, what does success look like in this system? How do we know we've actually succeeded in managing the seas? And this is a paper we're just working on. It's just about to be submitted. As soon as I can finish finding the last few references to be submitted. And this then says that this is inputters, those put materials into the sea, extractors, those remove stuff from the sea, the regulators, those controlling it, who's affected by all this, who are benefiting from this, and who are influencing this. And many of us on this call are the influencers. So we're saying, okay, where management succeeded is when each of these things fulfills something. And you can read this later. And it's the same, those 10 tenets can be shown to be successful when they do certain things, when they have key performance indicators, key control indicators, the monitoring is okay, they've delivered what society wants, they're creating the right communication, and so on, and that. And I shan't go through it now because I'm just about to run out of time, but we can say what are the lessons for measure. There's many aspects. So we're now starting to say, not only have we got all this management, governance, administration in place, all this science, but how do we know when it's succeeded, when we've done something? And I'm afraid you have to wait for the paper coming out, hopefully not too long, before you can see that. But as you see, we do have lessons now. So we do have all this background for written that. So we know from our aims is satisfied. We've created objectives for in the area, and we know management is successful when the objectives are met. We carry out actions. We know management is successful and our actions are carried out. And when our outputs are produced, outputs are usually reports and documents and so on. But most importantly, we know management is successful when the outcomes are achieved. And this goes back to what I said at the beginning as the messages there. Let's start off with the right objectives. Let's get the good science for this. Let's quantify these footprints that I talked about. Let's make sure we understand the connectivity. Let's collect data to use and use data collected, because very often, sometimes the data are collected, but they're not used. We can determine if management is working. We need the underpinning concepts. We're now starting to value the system, both in ecological and in social terms. And we now know what the governance is and how we harmonize this. And I say, we've got all this. The challenge now is putting it together in the right order. And that's what many of these European projects are doing, as well as SMMR that some of you are involved in. So I hope that's been valuable and interesting. If you slides, either the PowerPoint or the PDF of the slides, just let me know. But Chrissy is recording this, so hopefully you can get a chance to look at it a bit later. So if I stop sharing now and then put my video back on. So yes. Hopefully that gives us just a few minutes for questions, Chrissy.
Perfect. Thank you, Mike. Thanks for this great insight into your work and the systems used. Yes, and thanks everyone for your patience also. Sometimes we just have technical issues. I think that's normal with these webinars. Yes, we already have a question in the chat, so I'm just reading them aloud, but also feel free to unmute yourself if you like. So one comment is, thanks, Mike, for a very informative talk. I'm interested in the marine management approach you are working on. Have you shown this to government teams, and what response have you had so far? Do you see it gaining traction and being used in practice in the future?
That's thanks, Chrissy. That's a great question. Okay, yeah, we have many of these ideas have not only been shown to governments and managers, they've actually been devised with them. All of the European projects that we're involved in, they all have what we call high-level stakeholder groups, which are people all the way down from the European Commission coming down is involved in the project. So we are working with them, and I think the fact that many of those methods are being devised with them and then checked with them means that they are getting traction. Some of the things I mentioned, like 10 tenets and bow tie analysis and dapsy worm and all these, they have been taken up. I gave a credit at the beginning to Roland Cormier in Canada, and Roland, he's working with Department of Things now. It's very nice when you create various ideas, and then I see papers where the ideas have been taken up, or I hear of organizations have been taken up. Things like dapsy worm has been taken up. It's now in various forms around the world, like in OSPAR and the European Environment Agency, but it's the same basic idea.
Thank you very much. Mike, what would you prefer? Should people contact you for the slides, or should I just insert my email address?
Either. If you want to, if I send you I'll send you the PDF, and then if people want them, you can just mail it out.
Yeah, no absolutely. No problem.
I'm not possessive about my slides. If people want to use them and take them, fine. Mind you, if they get paid for using them, then I want some of the money. But apart from that, it's
right.
Joking.
No worries. I just put my email address in the chat. Please feel free to just contact me.
Yep.
So another question, how much success have you had in getting policies amended?
That's a really interesting question. Many people on here will be aware of things like the REF, the Research Excellence Framework, and if you remember, one of the parts of REF is what is called an impact statement, and in the last REF, or the one before that, probably the one before that now, we used one of the European projects, Devotes, in order to show how the project had amended the directive, the Marine Strategy Framework Directive. And sorry, my picture's just come up here and it's a bit scary. And we showed there the way aspects that I've been talking about here have been built in to policy. Right at the beginning, I mentioned a couple of the projects that IX have done in Abu Dhabi, where they've based their state of their environment report on DAPSIWORM. They have changed their system according to DAPSIWORM in order to look at the environmental management, going from not only from on the marine and coastal area, but they've used it on the land as well. So we were working within 2 projects on there. So we have had, I think there is success in people taking up these ideas to get these ideas taken up. But I noticed, I mean, some of the people on the call, I just see saw Dave Patterson's name and Trace Fernandez and so on. And we've all been working on some of these ideas for a long time. And I think we've changed the nature by the fact that you've got SMMR was created, shows that there was the need for it. And hopefully when all those projects are finalized, you'll see just how things come together. I just seem to be working on a parallel universe at the moment, because a lot of work I'm doing is related to European and others, but we're all working in the same way. And I think there is evidence that these ideas are being taken up.
Thank you. Another question. Is there a danger that some systems approaches disguise lack of knowledge?
I hope not. One thing that we've been doing, we did it firstly in the systems analysis approach, the paper we produced, and now in what is called Marine Sabres, which is the aim of the project is to try and create a simple socio-ecological system. Now, a simple socio-ecological system is a contradiction in terms. You can't have it there. So it's trying to be either simple for the way it's enacted or simple in an area it tackles. Now, one of the things we've had to do within that is build in the fact that you have to know when expert judgment is needed because you don't have enough information. And some of the people on this call have heard me say many times that let's split the need to know versus the nice to know. What do we need to know? Many of us here, we would like to know everything, life, the universe and everything, but what do we need to know? And then the other point is the 80-20 rule. The first 20% of the time you study something, you get 80% of the information. So it is deciding what information you need. And so the systems that we're designing, one of them that Gemma Smith in IX and John Atkins and Amanda Gregory in IX have been working a lot on is this socio-ecological system. It involves causal loop diagrams. But within the causal loop diagrams, we have to use expert judgment because we don't have all the information. It's then up to the managers to say, well, is expert judgment enough? Or do we have to spend a lot more time and effort to try and get all the rest of the information? So we're trying to make sure it doesn't hide the lack of information, but it does tell people where the information is missing and what we've done instead. And that's why many of these systems have now they've got confidence limits on them as well. And I think that's the way to go. So we have to be realistic. We can't say we know everything, but do we know enough for management of these areas. And I think as many people on the call there, they will realize that we do know enough for management. We will never know enough. I mean, how many research projects have we all done, and how many papers have read? We need more information. Well, sometimes we have to say, okay, we're not going to get that information. How do we manage? And business do this. Business has to manage in the absence of information, or even in the presence of bad information. So that's what we have to do. One of the things that I think I was hinting at all the way through this is we're treating the environment like a business. It's got inputs and outputs, it's got constraints, it's got information, and so on. So let's use business ideas, and then perhaps business, industry, and politicians will take notice of us.
Great, thank you. And thanks for the questions in the chat. But if there are no further questions, I'd like to thank Mike very much for his time today and giving us an insight into his work.
With pleasure.
It's a pleasure having you, and everyone have a great day, and hope to see you soon the next webinar. Thanks, everyone.
Thanks a lot, everyone. And say, if you need any information, just call me.